Welcome to Cosmic Compass, the channel where we navigate the mysteries of the universe together. Here we don't just look at the stars, we uncover the stories they tell about planets' cosmic events and the strange visitors that pass through our solar system. Imagine this: a mysterious object enters our solar system racing past the sun, moving so fast that it cannot possibly belong here. For the first time in history, humanity witnessed a confirmed visitor from another star system. Its name was Oumuamua. But here's the twist. Oumuamua is not alone. Our solar system, vast as it is not an isolated island. It is more like a busy harbour, occasionally welcoming travellers from the depths of the galaxy. Today, we are going to explore the story of these interstellar interlopers. We'll ask, what are they? How do we know they come from beyond our sun? What secrets do they hold, and what might the next one reveal? By retracing their paths and examining what little evidence they leave behind, we can start to piece together not only their nature but also the dynamic relationship our solar system has with the wider Milky Way. So let's dive into this cosmic mystery together. To understand why interstellar objects pass through our neighbourhood, we need to look at the very edges of our solar system. Beyond Neptune lies the Kuiper Belt, a region filled with icy bodies. And far beyond that, stretching almost a light year away, is the Oort Cloud, a vast spherical shell of trillions of frozen comets, bound loosely to the sun's gravity. Some of these comets occasionally plunge inward on long, looping orbits, taking tens or even hundreds of thousands of years to return. Most would have remained quietly in the Oort Cloud forever, if not for powerful gravitational nudges. These nudges often come from passing stars. You see, our solar system is not fixed in space. It is orbiting the galaxy, weaving past other stars whose gravity sometimes disturbs the fragile orbits of these icy bodies. A close pass, even several light years away, can be enough to send a comet tumbling toward the sun or fling it out, entirely exiling it into interstellar space. If this happens in our system, it must also happen elsewhere. That means the Milky Way is filled with countless wayward objects, each a fragment of a star system's history. Some are ejected forever, others get captured by new suns, and from time to time we happen to cross paths with them. Let's begin with the most famous of them all, Oumuamua. In October 2017, astronomers in Hawaii spotted an object moving unusually fast through the inner solar system. At first it was thought to be a comet and was labelled C2017U1, but soon something seemed off. There was no visible coma, no glowing tail of gas and dust. It was reclassified as an asteroid A2017U1. Yet even this didn't quite fit. When its orbit was carefully calculated, astronomers realised it was on a hyperbolic trajectory, meaning it wasn't bound to the sun. It had come from beyond, and after its brief visit, it would never return. This discovery forced the International Astronomical Union to create a brand new category of celestial body interstellar object. Thus, Oumuamua became I-2017U1, the first of its kind ever recorded. But Oumuamua's strangeness did not end there. Its brightness fluctuated dramatically, suggesting an elongated shape. Many artists depicted it as a cigar up to 800 meters long, but only a fraction as wide. Others argued it could just as easily be flat like a pancake or saucer. And unlike most asteroids, it wasn't spinning smoothly. It was tumbling chaotically, as if knocked by some violent past collision. Then came the most puzzling detail. As it passed the sun, Oumuamua accelerated slightly more than it should have under gravity alone. Normally, comets show this behaviour as gas jets erupt from their icy surfaces. But Oumuamua showed no coma, no dust, and even the Spitzer space telescope detected no infrared emissions. Was it venting only invisible gas, or was something else at work? Adding to the mystery, Oumuamua reflected sunlight more efficiently than typical comets, up to 10 times shinier, almost metallic. This sparked speculation that it might not be a natural rock at all. Some scientists even suggested it could be a fragment of alien technology, perhaps a derelict light sail drifting through the stars. Before we let our imaginations run, wild radio telescopes listened carefully for any signals. None were detected. If Oumuamua carried secrets, they were silent ones. Today, Oumuamua is far beyond reach, slipping into the void. We may never know its true nature. But what we do know is this: it was real, it was here, and it opened a new chapter in our understanding of the galaxy. Just 2 years later, in 2019, another interstellar traveller was discovered, 2I Borisov. Unlike Oumuamua, this one behaved exactly as astronomers expected. Borisov was clearly a comet with a large coma and a tail stretching tens of thousands of kilometres, nearly the size of 14 Earths, placed side by side. It never came closer to the Sun than the orbit of Mars, so it was faint and could not be seen with the naked eye. Still telescopes confirmed its size, about half a kilometre across, similar to Oumuamua. After rounding the Sun, Borisov began to disintegrate, as many comets of its size do. Its composition, while slightly unusual, was not extraordinary. In fact, Borisov's conventional nature was almost a relief to scientists. It proved that interstellar objects could look very much like the comets we already know. So while Oumuamua baffled us, Borisov reassured us: not every interstellar visitor is shrouded in mystery. Some are simply icy wanderers from other suns. Beyond these two, there are other fascinating cases worth mentioning. Take C1980E1, for example. This comet once had an orbit lasting over 7 million years, carrying it nearly a light year away from the Sun. But during a close approach in 1980, Jupiter's immense gravity altered its path just enough to give it a hyperbolic orbit. In a few million years, C980E1 will leave the solar system entirely, becoming an interstellar object itself. On the other hand, Jupiter can also capture such wanderers. Its powerful gravity acts like a cosmic gatekeeper, sometimes slowing down interstellar comets so they remain trapped in our system. Machholz 1 and Hyakutake, for instance, may be such captured interstellar objects, betrayed by their highly unusual chemical compositions and elliptical orbits. Then there is 514117 Kaʻepaokaʻawela, an asteroid orbiting in the opposite direction of nearly everything else in the solar system. Locked in a resonance with Jupiter, its retrograde motion suggests it could have been captured billions of years ago, its original identity long since obscured. Together, these examples remind us that interstellar visitors are not rare anomalies. They come and go, sometimes staying, sometimes leaving forever. They are part of the grand exchange of material across the galaxy. If there are so many interstellar travelers out there, why have we only spotted 2 confirmed ones so far? The answer is simple: our tools have been limited. Most are small, faint, and fast slipping past before we even notice. But that is about to change. One of the most exciting observatories of this decade is the Vera C. Rubin Observatory in Chile. With its enormous wide-field telescope, it will scan the night sky repeatedly, cataloguing asteroids, comets, and perhaps dozens of new interstellar visitors. And here's the most exciting part: space agencies are already drafting mission plans for when the next Oumuamua-like object is found. Instead of just watching it disappear into the void, we could launch a spacecraft to intercept it, taking close-up measurements and maybe even samples. The next interstellar traveller may already be on its way, racing silently toward us. This time, we might be ready. So, what have we learned? Oumuamua showed us just how strange and unpredictable interstellar objects can be. Borisov reminded us that some are simply comets, not too different from those we know. And hidden among our comets and asteroids maybe others, captured, disguised, or waiting to escape into the stars. Our solar system is not a closed world, but part of a galactic crossroads. Every interstellar visitor is a messenger carrying clues about other suns and other worlds. What secrets will the next one bring? Could it confirm our theories or defy them yet again? For now, all we can do is wait, watch, and wonder. If you've enjoyed this journey, don't forget to subscribe to Cosmic Compass. Together, we'll keep exploring the universe one mystery at a time. The universe is full of mysteries, and every visitor from beyond our solar system reminds us how connected we are to the wider galaxy. Each interstellar object is not just a rock or a comet, it is a messenger carrying secrets from distant worlds. Here on Cosmic Compass, we'll keep following those messengers, tracing their paths, and asking the questions that push us further into the unknown. If you enjoyed this exploration, don't forget to like, share, and subscribe so you won't miss the next discovery waiting just beyond the horizon. Until next time, keep looking up, and let's continue our journey through the cosmos together.